Hi all. Today I will tell you about another Kaggle competition. It's ASHRAE Great Energy Predictor III. What is the ASHRAE? ASHRAE is the American Society of Heating, Refrigerating and Air Conditioning Engineers, and they sponsored this competition to understand if the situation becomes better or not. As they said in the description of the competition, significant investments are being made to improve building efficiencies to reduce cost and emissions. And the question is, are the improvements working? So the competition goal was it is the regression problem, and we need to predict four main meters. It's the chilled water, which is the same with like cold water. It's a hot water, electric, and another electric is a stream meters. In Russian we have it like паровая энергетика, but in English it's like a stream meter. The competition metric was root mean square logarithmic error, which is the same as the usual root mean square error, but using the logarithm. Also, I would like to introduce my team. It was Thomas Yukota from United States, and all other participants are from Russia. It's Akasayama, Alexander Polyakov, Sergey Bransky, and me. We finished this competition in gold zone. Our solution was a big blend and stacking of regression models with leak cross-validation, and as a result, it's 29th place in public and 17th place in private leaderboard. What was the data? Actually, in training there was quite a lot of data. It's like 19 million rows with 1,500 buildings and 4 meters. And in test there were even more. It's like 42 million rows from same building, but for different period of time. So there was three main part of the data. It's weather data, building metadata about the year of the building, other information, their main occupation, like it's a building for education or it's a building for commercial things, and also meters usage data, which show us these 4 meters, which I already said about it before. And all this data was connected in a 3-year time frame, which was split between train and test by time split. I will start with the preprocessing of the data, because it's the main part of the solution for this competition, because the data was quite tricky and we need to handle it some way to get the good result in this competition. So the first we need to do is to remove animals for some building. As you see in the first graph for building, for a full data set, the data have a lot of peaks, which are unusual. And if we, for example, remove building 1099, which I think the animal is just some data which is not true, maybe some problem with the data, some with metadata or something like this, some bugs with the meters. And if we exclude this building, we see that the data set becomes better. We can see it in the second graph. The second step of the preprocessing, we add holidays. Because we had the timestamp, we could connect them to the American holidays as a New Year, day before New Year, Independence Day, Christmas Day, Christmas, and Boxing Day. Also, we fix square feet for building for some buildings, like 150 and 106, and for site 0, and added new features, square feet per floor, because for some buildings there was the square in some other units, so we need to normalize them for the same. Also, we fixed weather time mapping by returning time to local for each ID, because there was time in the local time, and we need to connect to the weather time, which was the same for all the data. Someone in this competition don't do it, and it gave them the very tricky data and worse score as a result. As a 5th step of preprocessing, we added exponential weighted average for air temperature for day, week, and month. And it gives us a more stable graph for weather over days. Also, we impute missing weather data with mean or the closest periods. So if some data for weather was missed, we imputed it with the closest, with the same period of before some interval or after it. Also, we added some interesting features. It's like relative humidity, like in Russian it's относительная влажность, and feels like temp feature. It's температура по ощущениям, using the library MeteoCalc. So, feels like temperature is a temperature which is equivalent perceived by humans, caused by combined effects of temperature, relative humidity, and wind speed. Because people use electricity when the weather is bad, so it was very important to understand what is the bad weather for people. Also, we added the simple timestamp features like time trend range or every hour and map timestamp to dict value of the range and order to understand each period for each building. Because if the first week of the for some building was like 1st January and for other building was other day of the week, so we just map them to have the same period. Also, we added the group. It's a quarter number of timestamp for cross-validation split, as we will see in the next slides. Also, it's important to say about our training pipeline. We had in this competition we had training set and leak set. Leak set was scrapped from different sources in the public internet, and we could use it in some way. So we apply our preprocessing to train data, and we got two sets. It's train set without leak and train set with leak. I tested a lot of models with training set and with combined leak, but it gave us a bad correlation with leaderboard, and we decided to just remove it. So for all our models, we used the training set without any leak in the training step. As a cross-validation, we used group CAFOLs by quarters with future selection. And we prepared around 14 light GBM, 25 CatBoost models, and 9 XGBoost models. So for each model, we prepared different feature selection. It's like a different combination, like light GBM with CatBoost feature importance selection features, like XGBoost with Baruta features selector, and etc. So after that, we use very famous techniques like linear regression stacking, weighted average ensampling, and also we choose some best single models which show us the best result. After that, we made the final blend using the leak. So we make the prediction for all our models on a leak, and find the parameters which give us a better score on a leak. Like we For example, we have 4 predictions, and we know that if we will take weight like 0.5, 0.25, and 0.125, and so on, we will get the best score. So we use these parameters for a final prediction for test in the private set. So this strategy gave us the 0.9043 in public and 1.244 on private set. It was our solution, but I would like also to say about solutions from interesting parts of solution from other participants. Actually, in first place, they used Savitsky-Golay filter, which allows them to get the air temperature graph more smooth. So it helps them to train models without any data which just gives some noise. Also, if you will be researching about this solution more, I want to advise you to read about second place solution, because they use interesting outlier cleaning process, and they gave us the understanding why they are doing it and why it is working. It's very interesting. I advise you to read it. Also, the good idea was from 5th place, because they added interesting target features. Actually, in all such competitions, target encoding is leaky, because it gives you some advantage, which usually give you the worst score on the data set which you have not seen before. But in this, it was very interesting, and it gave them the great advantage. It's like the first feature is for each building they calculated 5th and 95th percentile of values and added it to the training set. And also they added proportion of weekdays features for each building and meter. Like how for some building, how much energy for some meter was spent on Sunday, Monday, and etc. If you have any questions or comments, please ask.
Thanks for the talk. The first question is, what hardware did you use, MacBook or something better?
I have a very strong PC. It's like a 16 cores processor and like 96 gigabytes of RAM. So it's pretty enough for this competition.
Any other questions?
Hello. I'd like to ask about your cross-validation strategy. What do you mean by cross-validation by quotas? Does it mean that you have like 4 folds only?
We used group K folds by quarter.
Quota, is it a variable in dataset?
Oh.
What do you mean by quota? Is it like you split all the dataset in 4
like
parts?
we have the data like timestamp and some other features. And we used the quota from this timestamp and then used group K folds validation by quarter.
Any other questions? No? Then thanks for the talk. Let's read the speaker.